Okay, so the moment you creating a tensor object in PyTorch is just one line of code. You just call torch.tensor and pass the data or write down your own matrix. It will create a tensor object X. Okay, you can, since it is an object, it has an associated methods. One of the or few of the important methods are these. Okay, you can access how it is stored and what is the stride. I will discuss about the rest. The stride value, shape, device, which device, whether I need to compute a gradient, what is the gradient function, dimension, right? In addition to the NumPy, you can see few more new attributes like grad function, which are specific to PyTorch but not to general multi-dimensional array. Okay, and you should always check these things in order to decide whether it could be optimized. Okay. So now I think before moving on to the next things, the device thing is very important. Moving an element from CPU to, for the time being, you just remember this. If you have anything in CPU, want to move it to GPU, it is a costlier operation. Think whether you need to do that. If it is extremely needed, then you have to pay attention to this, something called as pinned memory. For the timing, you just note down, but if required, I will cover it later. Okay. So there are a lot of things, but I want to highlight a very few things. So you can also, of course, you can access this slide in the usual slide link in the deep learning lecture slides. You can go there and access this slide. To know the in-depth details of the internals, you visit this blog as well. Okay, it is nicely written by one of the developers of PyTorch, and you could get a lot of things out of it. And of course, I'm not going to cover them for the time being. I'm just going to skip it. So this is the final takeaway. In a single word, you can say whatever the tensor you create, it is going to be flattened internally. It is going to be flattened into a single dimensional array, C++ array or C array, whatever. It is going to be stored as a contiguous. All the elements are stored in a contiguous memory location. The logical view is just by making use of stride, you build a multi-dimensional tensor. It is just a logical view. It is not how the elements are stored in the real memory locations. Okay, now I am going to switch to Colab, and then I will switch back to this slide content after we get some few hands-on with the torch tensors. For that, maybe I share this link with you. You may follow along with me. I copy paste the things. You also copy paste and execute. Okay. Okay, by the way, if you have any questions so far, you can ask.
So I'm not able to understand this moving things from CPU to GPU. I understand you are going to expand this later, so I'm not going to try too much. But moving things means it should be in memory, but the only thing that these two things do is compute. So what does it really mean when you say moving things from CPU to GPU? If you can answer that, it's okay. Otherwise, I'll wait.
Okay. Moving things means you create, say, I am creating a 2x2 matrix on CPU. So internally, they are going to be stored in a RAM by following some format. Okay. If you really want to make a copy of this CPU, or if you want to really move the elements, means you have to copy the elements from the CPU and then somehow you have to convert that into a format suitable to GPU, right? So there is some sort of interaction. The GPU follows different way of storing elements, and CPU follows different way of storing elements. So if you want to move it, so why do we in the first case we want to move the elements from CPU to GPU? Because GPU allows me to compute things in parallel, especially the matrix multiplication. So whatever I have in CPU, where I define some sort of matrices or parameters of deep learning network, I want to carry out those operations in the GPU. So for that, I have to move the input and then all these models to the GPU just for computational purpose. So when I do that, there are a lot of compatibility things that you have to ensure. So when I say it is costlier operation in the sense, it takes a lot of time. Okay, so yeah, I will discuss these things later, but for the time being, you just remember something like this.
All right, thanks.
Okay, so just open a Colab at your end, or just let me know whether you are able to open the Colab I shared in the chat box, and I'm going to, you know, do this. So whenever I execute this, please let me know whether it gets updated at your end and you are able to see this, code. So shall I start? Have you opened the Colab and connected to the machine? In fact, I want to take the poll, but creating poll also takes some time. Okay. So the first thing is, as I mentioned in the start of this workshop, that when I offered this workshop, last time the version was different. Now it is a current up-to-date version, which is PyTorch 2.0 with lots of features. Okay, and specific CUDA. So if you really want to install PyTorch in your local machine, then you have to ensure a lot of things. What sort of, if you have GPU, NVIDIA GPU in your local machine, you have to see the compatibility by referring to the documentation. Okay, please be very careful when you install PyTorch. Ensure all the compatibilities between these hardwares. Otherwise, you will run into error. Okay, and it is very debug to debug the error if it is a compatibility issue. Okay, tracking this is because the error message thrown by the system is kind of not interpretable by us if it is a compatibility issue. Okay, now we are using this 2.0. Now I just want to know what this torch at the first place. Okay, so when I just type this torch, I just want to know it, how things are organized. So we can see that torch in itself is a module, and it is internally calling this init.py. Okay, so when you create a package, we all have this init.py. Okay, whenever we import the package, it is being referred to that init.py. Okay, this is a very typical thing when you develop a Python package, and I want to know what is inside this module. Okay, again, it is just an exploration. Whenever you learn something new, right, knowing how things are organized in this directory, all these are very helpful. Not for all the function, at least for the top level function. Okay, so you can see that when I read this top level torch module, you get some idea. Okay, so it says the data structure for multidimensional tensors that we have discussed, and also it provides an efficient way of serialization of tensor. Okay, so when the thing is that when you train your model, you want to, we know that the model takes days to run. Okay, so in that case, if I train a model for one day, then I want to turn it off, and then I want to continue the next day. So what we do is we typically store the intermediate weights, and then we retrieve it. So typically all the libraries usually provide this way to store the whatever the thing we want to store in by serializing it and then retrieve its state later. Okay, so that is also available in PyTorch as expected, and few more utilities. Okay, and beyond this, I don't really want to move into this, but I would, if you have time, okay, you just go through this. What are all the things are there in this init.py and how things get installed. Okay, even though it is not needed, but I advise to get some understanding so that when you debug, you will get an, if you know all this information, then when it throws an error, you can immediately correlate with these informations, right? So that's the reason why I'm asking you to go through this. And of
Hello,
course,
sir.
this, yeah.
So instead of focusing on the entire like file, this output, so can you tell
Mhm.
some specific which are important, which you need to like focus?
At this point, nothing is important, right? So because these are all sort of related to setting up things. So when you install Torch, it will look for whether it is in Windows. If it is a Windows, what to do. If it is an Ubuntu, what to do. So these are all the things specified there. And when you deploy the model during the runtime, what are all the models should be imported. So these are all the things you can infer from this list of lines, but that is not too that much important to develop a model or even for deployment.
Actually, as you told to know the internals, so like how can I know the internals?
Even I don't know the much of internals. So, if you really want to know it, and the PyTorch has a separate documentation for developers where they talk about various things. But even going through that won't be, you know, is not that much easy. So we have to refer to the blogs. But um, we have to set our boundary, right? Knowing the internals, even if you look into the contributors of PyTorch, right? In the beginning stage in 2017 or something, there were some 10 contributors who developed this core tensors, all these things. But now we have 2000 plus contributors who are contributing across different steps. They don't know about all the internals, or even no one in the PyTorch community knows everything about the PyTorch functionality. They specific on one particular, they focus on one particular area, they know all those internals. I think that's fine. We don't
Okay.
even,
Okay, sir. Sir, one more question, like maybe a novice question, but like what we are actually doing, like you told that someone is developer in this PyTorch or like that. So, what is the focus of like what is our focus actually?
sorry, can you repeat your question?
Like what is our focus? We are no, you said that we are not developing anything. So, like basically,
No,
what is our
now,
focus?
yeah,
Yeah.
now we are going to see what is a tensor, how to create tensor, and then how to understand the dimensions of the tensor. So, if you want me to, pinpoint one thing that we are going to learn today is about the understanding dimensions, and then applying operations on the tensors. So that is the objective of this particular, day. So that's what
Okay.
we are
Okay.
going to do now. Yeah, so if I call this torch.tensor, it says built-in method. It is not NumPy function definition, as you know, it is written in C++, so it says it is a built-in function. So everything is, when you call tensor, it is actually in fact calling the tensor written in CPP and pass the arguments through the wrappers. Okay. Okay. So I have a different collab which I shared in my GitHub. So which has so many maybe uh, details. If you want to refer to that, you can also refer to that. I share the link later. Okay, so as I mentioned, the tensor is the core component. So I want to really know what are all the things available in the tensor, because I'm going to manipulate tensor. So I should know not just creating the tensor. I should know all the optional arguments that are passed to the tensor. Okay, when I create a tensor. So you can see that, of course, you can refer to the documentation. Since we are in Colab, I am just using these commands. Okay, the data, it could be loaded, or you can create a matrix or whatever. Okay, you can pass a list or a NumPy array, whatever. And then the data type, usually it is a float or NumPy, sorry, integer, character, whatever. Device is one of the important arguments. Whether you want, usually it is created on the CPU, but if you can also create the tensors on the GPU, you can move the tensor from CPU to GPU as well. That we see later. And the other, or not only I say, the utmost important arguments in this while you create a tensor is required grad. Okay, so we know in deep learning model the input is a tensor, but we don't compute the gradient for the input, right? We always compute the gradient only for the parameters. So if I create an input tensor, I don't want to set this required grad argument to true, because I don't want the gradient for the tensor. But if I create a parameter tensor, I know later I want to compute the gradient for this parameter. So I have to set required gradient is equal to true if it is a parameter tensor. In general, if we, for some reason, any research reason or whatever, if you want the gradient for a particular tensor, you can set this argument to true. Okay. The other, yeah, final, but may not be, we may not discuss this about a much. Again, the pin memory, right? So this is very specific to when you move the move the tensor from one core to other core or from CPU to GPU, as I mentioned, it is a costlier operation, especially when we interact with this. So that is where we make use of this argument pin memory, but for the moment we can ignore that. Okay, so these are all the possible argument, or these are all the arguments that we pass to the tensor when we create it, and we have list of example. We just for the moment once again ignore it. We go step by step. Okay, so I hope all of you are executing at your end following these things. If you face any error, just let me know. Okay. Now I am going to create a tensor. Now you can see that I am just passing a single number, and then I am just executing this. You are saying it says tensor 9. Okay, that is what I print. The other thing is the shape of the tensor. The shape is actually empty, which means it is not a tensor, it is a scalar. Okay, and then the dimension, there is no dimension at all. It is simply a scalar with no dimension. So if you pass a single number to this argument without any brackets or nothing, just pass a single number. So this is a scalar. So if you want to access the element in a tensor, so typically we use this square bracket to access the elements, right? Being a Python list or NumPy, we follow the same. But if you try to access this, then it throws an error. Okay, so if you look at the error, it says invalid index of zero dim tensor. So we can note down this particular errors, right? These things will help you, especially when you debug. Okay, so what it says is that what I created is a tensor, but it is not rank 1 or rank 2 tensor. It is a zero dimension tensor. Okay, so for zero dimension tensor, the way it stores and retrieves is quite different. So we cannot use this square bracket when you create a zero dimension tensor. But if you want to access the number associated with this tensor, then we can use this item method. That is somehow equivalent to in general framework like in pandas or whatever, right? We call this dot item just to retrieve a single value. Okay, so this usually happens when you compute the loss function, right? The loss is ultimately going to be a scalar value. So if you want to retrieve the loss value at a particular time step, then you can call this dot item method to retrieve the loss value for each iteration. Okay, so of course scalars, the scalar value has a role in deep learning at multiple locations. So if you want to create a scalar value, then you can create the scalar value using this approach. And also remember that one of the important thing that I forgot to say, okay, maybe I should have told this earlier. So let's say you already have an experience in sklearn, right? So in sklearn, it is fine. I can make use of the model from the sklearn library, or I can write my own model in NumPy, and then I interleave those models with the existing sklearn functionality, which means I can mix these. I can write my own NumPy functionality, and also I can make use of sklearn, because under the hood they make use of the common tensors, common ND array. Okay, no problem. But when it comes to PyTorch or any deep learning framework, you have to bear in your mind all the time is that whatever the operation you want to do, it should be a PyTorch tensor. Okay, you cannot say I cannot create a weight matrix in tensor and then which is using PyTorch tensor and then the input in a NumPy array. Okay, you have to convert your input NumPy array to PyTorch tensor. You cannot simply say I have a NumPy array which is a valid array and then I have a weight matrix which is in PyTorch format. Then why don't I make use of it? Can you tell me the answer why it is not allowed? Can you correlate with the concepts that we have learned earlier? Why this is a kind of
Because it requires format which is compatible with the GPUs.
Okay, GPU is fine. Let's say I'm restricting to CPU. I'm going to do all the operations in the CPU only.
The TensorFlow frontend in Python actually calls into the C++ backend. So the data has to be converted from the Python interface in NumPy to the C++ interface that Tensor is eventually going to use in PyTorch.
Okay. Okay. So there are few answers, but the thing is that GPU is one thing. When you move to GPU, the NumPy arrays cannot be moved to GPU. The other thing is that when you here, when I create a PyTorch tensor, if I set one of the tensor, the argument of the tensor to which is the required grade. If I want the gradient of the tensor, one tensor you can compute the gradient for one tensor, you cannot compute the gradient for other tensor. So ultimately, to keep track of all these gradients, right, PyTorch is going to interact with AutoGrad module. So AutoGrad module expect the tensor, I mean the PyTorch tensor. So it's like if I pass the NumPy array, then I cannot compute gradient for that array. Okay, that is not allowed. So that is also one of the reasons. Okay, so please be aware. If you create an array, NumPy array for some reason, and if you want to carry out some operation with the PyTorch tensor and the NumPy array, first convert the NumPy array into a PyTorch tensor, especially if you want to compute the gradient for those operations. Okay, if you don't want the gradients, of course you can convert PyTorch tensor to a NumPy array. But if you want the gradient for those operations, you have to ensure whatever the operation you carry out between two entities, those should be PyTorch tensor. Okay, often you tend to mingle these two and end up messing up things. But please be aware of that. Of course, it raises an error, but being conscious of this also is good. Okay. So the next thing is about the storage. As I mentioned, you can also look into many values storage and then stride. But there are some now in the previous version of PyTorch, it is okay to call this storage method. Now they have depreciated this. I mean, it is not in the future. They may remove this storage method. Okay. By the way, we can see the storage is 9. All these things. So to suppress this warning, I'm just going to make use of others global setting for touch. So it minimizes this warning. Okay. Okay. Now, how do I create a tensor? Let's start with a one-dimensional tensor. Now you can see that earlier I just passed a single number. Now I am passing a number with one square bracket around it. Right. Same thing, but these two are different entities. Okay, you can say the previous tensor is contained number 9. This tensor also has number 9, but now it is a one-dimensional tensor, right? Because it has one. These dimensions are separated by these square brackets. So you can see the dimension is 1. Number of dimension is also 1. So this is kind of straightforward, right? Now, if I want to access the element, if it is an one dimension or more than one dimension tensor, then we can make use of typical way of accessing an element in Python list. Okay. Now you can get tensor with value 9. Okay. So you can also look into the storage, and then as I mentioned earlier, the stride value, you can do that. Of course, there is a warning, but just ignore it. Okay. The storage contains a number 9, and then you can see the stride value is 1. Okay. Of course, we make sense of this stride value when we create one-dimensional array with some n elements. And one thing you should focus is that now I'm creating, I mean putting a same number 9, but in 2 dimension. Okay. Same number 9, but it is residing at the second dimension, right? Okay, now focus on one thing. I am accessing an element. What is that? Okay, so what is your observation, right? So in the earlier case, I accessed an element, it prints something like this. Now it prints something like this. What's the difference?
It's returning a tensor.
Yeah, earlier also it's a tensor, right? Tensor 9. Now you can see the square bracket, right? So my original tensor, right, x is in fact residing is a 2-dimension, but after accessing it, I lose 1 dimension, right? Can you note that? Are you able to understand what I am trying to convey? So here what I had is 1 dimension, but after accessing an element, I lose the dimension. It becomes a scalar. Here I have 2 dimension, but after accessing the element in 0th dimension, again I lost the 1 dimension. Now it 2 becomes 1. So I am losing a single dimension whenever I access an element. Do you think this is an issue?
Maybe the item function will resolve that.
Accessing see, the question is, I have a tensor with some n-dimensional tensor. I am accessing an element at a particular dimension. The return tensor loses 1 dimension. Okay, so it loses, in this case, the return tensor dimension is 1, but the original tensor dimension is 2. So by accessing an element from a tensor, I'm losing 1 dimension. Could this create some problems later? Can you think of, or is this very important to know, or it is just we can ignore and just move on?
Sir, this is almost like Python list, because if we have a list of list and we access x of 0 there, so it will
Yeah.
give something like this.
Yeah, that is similar to that, but is this a problem? That's what I'm asking. So it is returning something, but I'm saying that 1 dimension is reducing whenever I accessing an element. So what sort of problems it could cause in the later, because tensors are going to interact, right? It is not going to stand alone.
Matrix multiplication, the dimensions could be an issue. The dimension compatibility between two matrices when I'm performing a multiplication could be an issue, because the dimensions are not consistent.
Yeah. So let me tell you, if you create a model and if you're creating everything from scratch, right, the most often you are going to encounter with dimensionality problem. Okay, so you execute something, at some step it throws an error. You look into the error, it says the dimension is not matching. You see, you tell yourself, right, everything is fine. Then why is the dimension not matching? It's because internally or by somehow you are accessing an element, but it loses the dimension. You are carrying out some operation, then it throws a dimensional mismatch error. But if you don't know, when you access an element, it is possible that the dimension may reduce in the return tensor, right? Then you will end up into, you have to spend a lot of time why this is happening. Okay, so this is extremely important. When you access an element from a tensor of multidimensional tensor, if you are accessing a particular dimension, you lose one dimension. Okay, you be aware of that. So that's what I wanted to. Of course, till now I'm using just single dimensional tensor just to illustrate the various concepts, but I hope the same thing is true when you go for 2-dimensional or 3-dimensional tensors. Okay, that's fine so far. Now let's create 1-dimensional tensor. Okay, you can create a list and do all this, but I'm just creating some random integer by just passing this size argument. Okay.
So one thing I notice here, the x dot shape is returning on an object called torch dot size.
Yeah.
So is that a matrix, an array? What is that?
Yeah, it's an torch tensor once again. So you can, if it is like numpy, when you ask numpy size, right, it returns an n-dimensional array, right?
Yeah, but it says torch dot size.
Yeah, because I'm not assigning it to anything, so that's why it's returns torch dot size.
Okay.
Yeah, one thing that you might. Oh, no, sorry, I'm using a different Colab. Sorry. Okay. One thing that you see is that here it says 1, 1. So what is this 1 and 1 refers to? Can you decode that? Or it says we have 2 dimensions, right? This is actually telling me how many elements are there in each of the dimensions. So in the first dimension, I have 1 element. In the second dimension, again, I have 1 element. But the shape of the element changes as you move into the dimension. In the first dimension, I have 1 element of dim1. the second dimension I have one element of div 0. Okay, so of course when I create some higher dimensional tensor, you can understand those things. Okay. Yeah, so here we are creating a simple one-dimensional tensor. Okay, so you can see that the number of dimension is 1 and the size returns 2, which means there are 2 elements in the single dimensional tensor. Okay, that's what it means. Now I just move on, create a matrix. Okay. Again, it's a random matrix. So I hope you know all these things, why I am passing this manual seed, all these stuffs. Okay. Now we know it is a two-dimensional tensor and the number of dimension is 2 and the size says how many elements are there in each of these dimensions. So in the first dimension there are 2 elements, each of size 1 by 2. Okay, so these the 2 elements are this 0, 2, 1, 1. So each of the elements are each of size 1 by 2. And then it also says in the second dimension there are 2 elements, and of course they have to be scalar 0 and 2. Okay, it contains only 0 dimensional tensors. Okay, and then you can of course keep creating n dimensional array, but before moving on to 3-dimensional and 4-dimensional array, I would like to illustrate the concept of storage and stride, all these things. Okay, so, I got some spike. Okay, so now I am calling this x dot storage. Yeah, it raises so many warnings, the same warning. So I don't know why it is not working. I executed this, but it still raises warning. Okay. So what it says here, in fact, this is a logical view, right? So I told you when you create a multi-dimensional array, what you are actually doing is creating a logical representation of the elements stored in a memory location. So in memory, the elements are stored like this 0 to 1, 1, which means 0 to is, all the elements are stored in a contiguous memory locations. So 0 is the first element, and then 2 is the second element, and the 1 is the third element, and again 1 is the fourth element. So we say it follows which order, row major or column major. We have to follow some order, right? So in this case, typically in most of the framework I know follows this row major ordering. MATLAB I think follows column major ordering. Okay, but you should be aware at least which order it is actually following. Okay, so keep this thing in mind. Now I'm going to switch to the slides. So if you have any doubt so far, or if you want to take some breath, I can give you 2 minutes.